Chuck Hart with the Elkhart Model Railroad Club, and tonight we're going to talk about LEDs and resistors. So we'll get right into that, and basically it's the effects of lighting your model railroad equipment. So that's where we're going to head with this presentation. But first, you know me, I like to do some history on the presentations. Early days, it was mostly light bulbs, tiny light bulbs. There were dozens and dozens of different kinds through the years. They have improved. You can see on here we've got Markland has light bulbs in like 5 or 6 different voltages. Athearn and Atlas usually had bulbs that worked between 12 and 16 volts. The other little ones that came out later in life were grain of wheat and grain of rice. They're very small, and I have some here to show you those. But the drawbacks of light bulbs are they take up a lot of space. You really have to know the voltage of them to use them. The current can be high. I have some light bulbs here that are like grain of wheat size, or the ones on the upper left from Markland and the upper right from Athearn. Those things ran about 80 to 90 milliamps sometimes at the proper voltage, and we'll talk about why that's bad for your decoders. And then the little guys, they finally came out with some colors. So the idea was to get away from light bulbs if we could, but in the early days you couldn't do that. You had to go with bulbs. Model Power used to sell a pack that you could get various ones. This was usually a display in some model railroad shop, and you could pick out the model number or the part number you needed for your particular brand of locomotive. But you can see that there's all kinds of different voltages listed for those bulbs, even though they're different. Same size. So that was difficult to find the right bulb. So let's talk about the LED history a little bit. LEDs have not been around very long, surprisingly, in terms of light bulbs. Back in 1907, Harry Round discovered that he could take some dissimilar material and make it light. And through the years, LED history improved to the point where, 2007, the government said we can't use incandescents anymore. So here's Mr. Round, and you can see his array of test equipment back in 1907. And he was trying to figure out how to make something light up without using a heated filament. And that was this little thing that you can see over his left hand there that looks like pieces of plastic or whatever. He had some sort of material on there, and that was lighting up. Basically, it was electroluminescence. It wasn't really a light-emitted diode. So, but he was one of the first guys to discover that you could take dissimilar material and apply a voltage to it and make it glow. So, in 1961, these two guys started, they were from IBM, and it took them a number of years, but they finally realized that they could encapsulate the material in a small container and put some voltage to it. And these guys here were actually the fellows that created the first operating LED. So that was Pittman and Baird. And it looks like the test equipment's improved since 1907. The development, though, started again back in 1907 up through about 1994. So again, it's not been very long that we've had LEDs. And the first practical one back with these guys, 61, 62, they created the SRX 100, and it's about the size of about it looks like a transistor can. If you know what they look like, they're about 3/8 or a little less in diameter and same height. They had 3 legs on them. and that was their first LED. The top was a membrane that allowed the light to show through, and that's how the LED was able to be seen. They created yellow ones. It was a yellowish color. They created a blue one later in life, and then in the 80s we finally got around to orange, yellow, green LEDs, and 94 was when the blue LED was actually perfected. And all of these things, all these colors are created with different materials inside the container. 1994, bright white, and we'll talk about that a little bit more too. LED design, I won't go into all these too deep. The standards were red, green, and yellow. Then the blue LEDs came in, like I said, in the 90s, and white LEDs were actually, if you know anything about the color spectrum, and if you shine something through a prism or light through a prism, you can't see white. You see all the other colors, but you don't see white. So they had a tough time trying to figure out how to make white LEDs. What they finally ended up doing was taking a blue LED and putting a material over it and caused the blue to diffuse into white, or white light, what we call white LED. And then depending on the diffused material, then the white was either bright white or yellow light or dim white, whatever you want to call it, you know. So, but your white LEDs are blue with a material on it, and that might be. I've seen some white LEDs that have a bluish tint. I don't know if you've seen that. Mm-hmm. Well, that's because you're buying a very inexpensive LED from some other country, probably, that is not doing a good manufacturing job of making a white LED. But it's actually a blue with a diffused material on top of it to make it white or yellow. So today we've got LEDs that are readily available. I've got some here that I bought probably in the late 90s that were about $1 or more on sale, and today you can buy them for a few cents finally. And so the various LEDs, 1.8 to 5 millimeter, are the leads. What I mean by the leads, they have the long leads on them. And then the SMD, or surface mount device LED, are the smaller ones that we like to use in our locomotives or some buildings and things like that, street lights, so forth. Those are surface mount LEDs. And those are designed for printed circuit boards basically, but our manufacturers are putting wires on them so we can use them more practical. So SMD, polarity and size, you can see that there's the 0201 is really small, and it only, unlike the bulbs, they only require about 1/20th of a watt of power, and they'll only run about 10 milliamps instead of 50 or 60 milliamps in a light bulb. So again, they're very efficient, these LEDs. And then there's ways to identify which way is the cathode and which way is the anode. And that's something you'll want to know, because the LED only works with DC, generally, and the DC must have the negative on the cathode and the positive on the anode of what they call the LED two leads. So I've got some up here, and you guys can look at them sometime. They're up here someplace, where I think mine are the ones with either the dot or the chipped corner for the cathode side. On the LEDs at the top, they're signified with either a short lead or a long lead, and the short lead is the cathode and the long lead is the anode. So the short lead would get the negative and the long lead would get the positive. Nominal voltage drop. Now here's what I like about LEDs, is they all work within almost the same voltage range, unlike light bulbs that work between 1.5 volts to 16 volts, depending on which bulb you're using. You can see that the voltage range on LEDs are anywhere between 1.8 and about 3.8. So it's, and they'll all work at about 2 volts. So that's really convenient for us. The forward current, 20 to 30 milliamps. If you take a look at these two pictures, by the way, or two charts, you'll see that one is slightly different than the other. And if you go to 10 other sites on the internet, you'll see that they're slightly different as well, because people haven't really decided that a white LED is going to work between 3.2 and 3.8 volts. Some of them will say the white LED will work between 3.2 and 3.6 volts, which is, you know, we're talking 1/10 of a volt here. It's not a big deal. So if you pick a voltage that's in between those values, your LED is going to work just fine. Right? But this is a handy chart to have. We'll get into resistors a little bit. We'll talk more about LEDs later, but we'll get into resistors. The resistor, the idea of having the resistor is to drop part of the voltage, because if you don't have a voltage source that's 3.2 volts, but it's 9 or 10 or 12 or 5, you'll want to drop part of the voltage before it hits the LED, so that the LED operates within its voltage range requirement. So resistors come in all kinds of sizes and types and styles and values, and I have a number of those up here on the table. What we'll probably deal with our models are the radio type resistors on the right hand side, the brown ones with the color stripes, or the blue ones with the color stripes. The brown ones are a carbon type resistor, and the tolerance on those, let's say if it's supposed to be 150 ohms, it might be 140 or 160, right? But it's going to be close to 150 ohms. The blue ones, they are made out of a metal oxide material instead of carbon, and they're much more accurate. So if they're supposed to be 150 ohms and it's still 10%, it's probably going to be 149 to 152. Much more accurate tolerance on the blue resistors, and I have some of those up here someplace too, probably in my resistor box. So those are the type of resistors we'll probably be dealing with generally. How many people have installed LEDs with resistors? Most of you. Good. All right. The next thing here is the resistor color code. The top one is the carbon type, or they're usually brown. All right. So the blue ones will have more color bands on them than the brown ones, and you can see from this chart the what's been added on here is four colors for your resistor value, and then the fifth color is a multiplier, and the sixth color is a tolerance, unlike the older carbon type resistors where you only have 3 colors for value and the fourth color is tolerance. Now on the bottom one you might find a blue resistor that has an additional color band, and that's for a temperature coefficient, and believe me, you don't need those. All right. There is another band that you might see on a blue bodied resistor, and that's, like I said, a temperature coefficient value. Just like the LEDs, resistors have leads that are designed to hook up to wires. There are resistors that have they're called surface mount, just like the LED SMDs, and they are soldered to a printed circuit card. And so if you get some of those and you're going to use them in some of your devices, just keep in mind a couple of things. They're low wattage rating, and you have to know how to read the value of the resistor, or you could use a meter to read the value of the resistor. you see the picture here, but these things are just like the 0206's LEDs. These things are tiny, all right? So I won't go into it too deep, but the 391, for instance, is 390 ohms. So the first number is, the first 3 is 300, 9 is 90, and the 1 is 10. All right, so it's 390 ohms. If it's 270, for instance, the 0, it means there's no value there, so it's just a 27 ohm resistor. And then the bottom two have got R's in them. That's a decimal point. So those things are going to be very accurate resistance. So there's like one, I think it's 30.9. I guess they're both 30.9 ohms. And this help explains that a little bit more. So, again, this is going to be on the web groups list, so you can download the clinic anytime you want to see it. All right, so when we talk about the dropping resistor for the LED, we're going to use a pretty basic formula, and that means that you're going to have to know something about Ohm's law. Not the whole law, but enough to get a dropping value for the LED. So we're going to use the following formula. The resistor value is going to equal the battery voltage minus the LED voltage and divided by your desired current. So getting back to the desired current, the LED is a current device, not a voltage device. So you can change the value of the resistor slightly and then change the brightness of the LED by doing that, because you're going to change the amount of current that goes through the LED. So instead of 10 milliamps, you might have 20, or you might have 30 milliamps as you adjust the voltage, the value of the resistor. So the LED is a current device. So we're going to look at some different types of circuits for LEDs. And in this case, the LEDs are in series. You only need one resistor. That drops the 9 volts down to the desired voltage for the LEDs. Oops. Here, a red LED is how much? 1.8 to 2.2 volts is the desired voltage for that.
Yep.
Right? And so a desired current would be 20 to 30 milliamps. Right? And those are in series. And that's what I have. These three resistor or LEDs are in series with one dropping resistor. So if we turn that on, we can see those guys show up. We'll use the camera here in just a little bit. I'll get through the presentation because we're going to do some of this again with your help. But these LEDs are in series and one dropping resistor, and that's we'll find out what that voltage is when we do the exercises. If we want to take and put the LEDs in parallel, there's two ways to do that. And that again is with one resistor and 3 LEDs, and that would be this guy. Those LEDs, all the cathodes are hooked together and all the anodes are hooked together, and I have one dropping resistor. So that is the diagram that's on the left. So that's one way to do parallel. So all the cathodes are together. But you can see in the series one, it goes cathode to anode, cathode to anode, cathode to anode. In this one here, it's all cathodes are together and all anodes are together. And we'll look at this a little bit later with the camera on, so you can see what I'm doing down here. The next way to do LEDs in parallel would be to have a dropping resistor for each anode. So that's what we have here with these 3 LEDs that are lit. We have 3 LEDs that are in parallel with a dropping resistor coming off of each one on the anode side, and then the anode goes to the or the resistor goes to the positive side of the power source. So we'll leave that on for a minute. When we talk about decoders, your decoders have got, oh, there's something, connect, good. All right, so a decoder has a number of things that are called function outputs or auxiliary outputs, and they're usually rated at about 100 milliamps at the max, and about 12 to 14 volts. So you'll want to check your documentation on whatever decoder you've got or purchased to find out how to use that auxiliary or lighting output. Generally speaking, the blue wire is a common, and your white wire, yellow wire, or purple, or whatever else you've got will be your auxiliary outputs. So you can take a meter and put your meter on the blue wire and then measure each of the other individual wires to see how much voltage there is. So in this case, this is a decoder that has 3 outputs, yellow, white, and green.
Yeah.
I think it is green, right? Each one of those is rated about 100 milliamps. And if you're trying to use that with a light bulb, what happens with these light bulbs is, remember the old power packs? You turned up your power pack and your train would slowly creep up and go, all right? And the light bulb would get brighter and brighter as you turned up your power pack. With decoders, those voltages are there all the time, and they're max. All right? So there's, even when you turn up your throttle, your light bulb is bright now. Right? Now you can change some of those things with CV settings, but the problem with that is that when the light bulb, these little guys here, when they see that sudden 12 or 14 volts, and they're not designed for that, they have what's called a rush current that comes out of the circuit of the decoder, and it could be more than the light bulb can handle, and you'll burn out your bulb. Right? Yeah, as Paul goes. You know, so you can use a drop-in resistor with your bulbs, but there again, you'll need to know the correct voltage for your bulb, and usually about 22K, I think it's 22K, it is enough to limit the rush current coming out of your decoder. Is it 22K or 22 ohms? You ever try those, Matt? Okay, I don't blame you. I don't want to use them. They're too different. LEDs are better. So, but again, each one of those outputs on the decoder is rated 100 milliamps, and that's usually max. I don't know of any decoders that will provide more than that. So, but again, if you're going to use LEDs, you'll want to know what that is, voltage-wise, and then you'll use your drop-in resistor to create your lighting effect for your decoder. So there's a number of ways you can test LEDs. I like the one on the top, the LED mini light tester. Those are all over Google if you want to buy one. They're usually between $5 and $10. I think they're about $7 on eBay. And you can, I don't know if you can see that in the picture up there, but here I'll pass both of these around. I've got the one that's no longer white. I've probably had about 25, 30 years. And the one on the left, or the one that Bill's holding, the white one, is come up from a company called Linrose, and they're still in business as well. So you could buy theirs. But the nice thing about those is you could plug an LED in them, and they already have resistors in them. They run off of a 9-volt battery, and they have resistors in them, and they limit the current to, I think 10, is it 5, 10, 20, and 50, or 30 and 50, something like that?
Starts at 2.
Oh, 2, okay. So you can plug an LED in one of those and say, okay, I like that brightness. All right, and you look at what you're plugged into. Well, I've plugged into 10 milliamps. All right, so when you go back to this guy, all right, you could say, okay, my current, which is IF, the bottom of the formula, is going to be the forward current of the LED, so you plug in 10 milliamps into that part of the formula, and your power source, maybe you've got a decoder that puts out 14 volts. So your V CCC or circuit connected voltage is 14 volts. Right? So you can work the formula and find out what value of resistor you need by transposing the formula. Right? So we're going to work on that a little bit, and just a little bit when I do the exercise sheets.